In this video, I'm going to show you how you can use large language models to threat model any repository, skill, thing that you're developing really quickly, really easily, but most importantly, really effectively. Honestly, this particular skill is an absolute game changer when it comes to developing secure, well-built software. It alone has the potential to revolutionize the entire software development process. So let's get into it. One of the things I've learned over the years of doing software development and cybersecurity at the highest levels is that threat modeling software at every stage of the process goes a long way to eliminating the complex multi-layered threats that software developers face on a day-to-day basis. The problem is, up until now, doing this effectively has been really challenging. It's a specialized skill that takes a ton of background information, and honestly, it takes a long time to just develop that knack for doing it well. As a result, what that means is that most developers don't do it until right near the end of the process, which means that when threat modeling happens, it becomes really challenging to unpick all of the problems and fix them. Effectively, in some cases, you end up with a full rewrite of your code, which is just not feasible for large multi-layered applications. This then creates a compounding issue where threat models are never done right from the start, and as a result they just get more and more behind, and you end up with all of these complex multi-layered threats to your software development environment that attackers exploit on a day-to-day basis. Now, today I'm going to introduce you to a skill that I think takes that particular problem and flips it on its head, provides a really good solution. I will say up front though, I'm not convinced that large language models are fully there yet. I would still recommend that you use experts to do this well for you. What this does do is creates a foundation to start solving this problem, and I have every confidence that as more and more powerful large language models get released to the public, we will find that this threat modeling gets more and more accurate. The result of plugging this into your overall software development process is that your software will become more and more robust. Effectively, what you're going to be doing is every single time you release a PR, or you update a new feature, or you even start a project from scratch, you will threat model the impact of whatever you've done. This creates a living threat model document that your AI can refer to all of the time. And my hope is that as I get more and more experience in this area and add more and more complex skills, I'll be able to include things like Burp Suite to test your web applications and a whole bunch of other security tools that I've either developed or used over the years to do this better. My theory is that if we can include threat modeling and then a later skill which will allow you to test those threat models against your live code, you will find that you will just eliminate whole classes of bugs and vulnerabilities right from the start because you have done it all the way through. And so the common issues that software developers just seem to not get right will be eliminated almost automatically without you even knowing that they were there in the first place. I'm pretty pumped about the whole thing, to be honest. So personally, I think that this particular skill is the start of a revolution in software development, and I think that once it gets to the stage where it is equivalent to some of the cybersecurity experts that I've worked with over the years, we will just see software security go to a whole new level. So let's get into it. I'm going to be referring to my laptop here. This is a very technical skill. I want to make sure that I get it right. So how does this actually work? Well, I've broken it down into 10 steps. I'm going to quickly run through them here, and then we'll expand them a little bit more in the video. So the first thing it does when this threat model runs is it reads whatever your target is. So that's either going to be a repository, might be a subsystem, a feature, might be an automation, it might be a PR that you're releasing. You tell it what the target is, and you can set this skill up so that it's done automatically for you, and it will then read the files that are referenced. Now, this is very important. It uses your files as the basis of its threat modeling. It doesn't just apply a set of generic threats from whatever thing that you're using and go from there. It will read your particular repository or your particular target to get that information. For instance, if you have API endpoints, it will then start to give you threat modeling around API endpoints. If you don't have API endpoints in your code, then it won't. And that's very important because honestly, that just saves you a ton of time and a ton of wasted generic advice that actually isn't that helpful. From there, it builds a threat model based on those real files. It will separate out things like your runtime, your CI build, and your dev test surfaces and apply threat models to each one of those. So if you have a dev environment, there's a different threat model that's going to be used from your production environment. It will then identify trust boundaries and risk-driving assets. So things like your inputs, how they're modeled, that sort of thing. Then it will define attacker capabilities and non-capabilities. So it will effectively come up with a picture of the threat actor that could be referenced for this. And then it traces concrete abuse paths from entry to the boundary, to the asset, to the impact. We'll then rank each path by likelihood and impact, record those assumptions instead of pretending unknowns are facts. It will write your target threat model report, and then it will run that report checker so the output has the required. Now, while this sounds really awesome, I do want to refer you back to what I said at the start of this episode. Large language models are awesome, and in reality, even starting to generate something like this, if that just cuts out like the bottom tier of low-hanging fruit for making your code more secure, it's immediately a win. However, like some of those things like the attacker modeling, starting to model like, your threat actors, that sort of stuff, that requires very advanced analysis, and whether it's deliberate or because large language models aren't there yet, you will generally find that it doesn't get all the way there. What it does do is take the really generic things that are covered by your OWASP type things and make sure that they don't exist in your code. Like I said, 100% amazingly better than nothing, but not ready to replace proper threat modeling just yet. It just makes your code more secure than it used to be. Now, how does this actually work together? So this particular skill has a whole bunch of components that work together, and in the description you'll be able to see a link to that specific skill as well as the generic production AI repository that all of this is based on. There's a whole bunch of components that are covered by it. Now I'm just going to reference a few of them and you can see them coming up on the screen there, but like I said, go and read the documentation if you want to know more. But here's a few of the components that are referenced in there. So I've also included in the repository a flowchart on how all of these components work together. So you can go through them and start to work them out. I'm going to quickly read you through what happens now. So first of all, it looks at the repository or subsystem that you define as being in scope, and you can feed it that from your large language model. So you can set up something like you'll see in my PR review skill, every single time there's a PR review, make sure that that's in scope. It develops a system model, figures out your endpoint stores and integrations, then your trust boundaries and assets, goes through your attacker profile, abuse paths, likelihood and impact priority, recommended mitigations, and your threat model report. Develops all of that for you. It then creates a report at the end that is constantly updated as your code goes through its reviews. So for instance, if you're developing a large code base and you have multiple PRs, you set it up so that every single PR that threat model is read, assessed, whatever changes are needed to be made, and away it goes ahead and checks them for every PR release. When you're using your feature design pre-flight, you can develop a threat model for that, and it will update your overall threat model for the whole project so that that threat model is always underway. For instance, if you were to have a look at some of the skills that I've developed for this particular production AI, you'll see that every single one of them is accompanied by a threat model for it. A really cool one to look at is the Docker one, which I'll be covering in the next episode. So Docker one goes through and makes sure that your laptop isn't building up all these like random Docker artifacts and clogging up your hard drive. So there's a threat model for that. What happens if someone got in and started to tell it to delete random Dockers from there? Like it goes through and covers that for you. It ranks all of those paths by likelihood and impact. And again, you can absolutely get into that skill yourself if you want to come up with some different weightings for that. But the idea here is it starts to template and codify how to go about modeling threats for a given target for your repository, and then ensures that they are read every single time you need to do something new. Now, this particular skill is actually used by a whole bunch of other skills in the production AI conglomerate. For instance, clarify before build will call this skill to threat model whatever it is that you need to build by the end of it. When you do things like a full app review, which is another skill that I'll be covering later on, it will call this threat modeling to make sure that the threat model is up to date and to test to make sure that the threat model has been covered by your large language development. Ultimately, what happens from here is that this particular threat model report then becomes part of the overall way that you approach your code development. And best of all, it happens independently of you needing to call it. Every single time you go to create a new feature for your app or create a new app, this skill will be called automatically. And that means that you will find that your code consistently includes all of that information right from the start. Hopefully that all makes sense to you, and hopefully you're also starting to see why I'm so excited about the possibilities that large language models are opening for effective code development. I started this series by making the claim that I believe that large language models are going to fundamentally reshape the role of software development, and it's going to lead to better, more effective code and more code overall for humanity. And I think that that's a very compelling vision. I'm very excited by it, and I really feel like we're starting to see it come to life. It's skills like this that, to me, completely redefine software development. They take something that used to be a niche, hard to access skill and very expensive to do well, and turn it into something that, while it's maybe not 100% there yet, it's definitely 30 to 40% there, and that's 30 to 40% more than what most software developers had in the first place. If you like what you're seeing, please don't forget to subscribe to my channel and sign up for notifications so that you learn when new content comes out. If you're also interested, I'd love it if you drop some stuff in the comments about what's standing out to you, what you'd like to hear more about, or maybe you just disagree with what I'm doing in the first place. 100% open to that as well. Whatever it is, I hope that you're enjoying this series, and I'll see you in the next episode.